In the previous videos, we worked on finding the present value and the future value. So the PV in the equation and the FE in the equation. If you haven't checked out those videos, they'll both be linked in the description below. And this video will focus on finding R, or the rate, given the present value and the future value. We'll go right into a numerical problem here. Today you make a deposit of $50,000. You plan to retire in 25 years and need $100,000 in the account. What annual percentage rate must you earn to reach your goal of $100,000? When solving problems like this where we're given the future value and the present value and also the t value here, so the t value is the number of periods or years in this case, so we know t is going to be 25. When we're given the information of the future value and the present value and t, we can solve for r using this formula. When we sub in the information, this is what we should come up with. We have the $100,000 future value, so this is the amount that we need after the 25 years in the account. We have the $50,000, which is the present value, or in other words, the amount that we're depositing today. Then we have 1 over t, which is 1 over 25, because we plan to retire in 25 years. And when you work through the math, you should come up with 2.81%. This is rounded to 2 decimal places, so don't panic if you come up with something slightly different. What this 2.81% represents is that if we deposit the $50,000 today and we want $100,000 in 25 years, it would have to grow at an annual rate of this 2.81%. So that's the significance behind it. In the first part, we concluded that in order to meet our goal of having $100,000 in 25 years, when we make a $50,000 deposit today, we would have to earn an annual percentage rate of 2.81%. In part 2, it says, assume now you need the $100,000 in 20 years. What annual percentage rate must you earn? Pause the video for a second and try and answer this question and see what you come up with. Right away, you should think that the future value is going to stay the same. We still need the $100,000, so FV will stay constant. The amount that we deposit today is also going to stay constant at the $50,000, so we know the present value also stays the same. What changes is the variable t. We now need it quicker. We need it in 20 years instead of 25 years. So this is what you should have came up with. Notice that the only thing that changes is this denominator. Previously, it was 25 because we planned to retire in 25 years. When we cut that down to 20, it became 20. When you calculate this formula out, it comes out to 3.53%. We notice that that is higher than the 2.81% in the previous problem. This is because the $50,000 that we're depositing has less time to compound, and therefore we'll have to earn a higher rate of interest if we want to meet that same goal of $100,000.